Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering new topics being added to CCNA exam 200-125. This is section 1.2 Network Troubleshooting. Upon completion of this section, you should be able to describe how to use the show commands for network troubleshooting. Basic troubleshooting approaches. Troubleshooting is being able to analyze the problem, determine the cause of the error, implement a plan of action, and then resolve the network issue. Commonly, all this is done in 6 steps troubleshooting methodology. So step 1 will be identifying the problem. The first step into the troubleshooting process is to identify the problem. Usually, the users will come and tell you there's a problem. So the tools that can be used for this step is to have a conversations with a user who's reporting the problem. Step number 2 is to establish a theory of probable cause. After you have talked to the user and identified the problem, you can try and establish a theory of probable causes. This step often yields more than a few probable causes to the problem. Now, if the user reports a problem, you can't go in a user's words. So yes, you listen to what they say and you talk to them, but then you have to go and check that there is actually that is the problem. And then after you check, you can identify a probable causes. 1 or 2, 3 things maybe you think, okay, well, that could be the problem, that could be the problem, and so on. Number 3 is test the theory to determine the cause. Based on the probable cause, test your theories to determine which one is the cause of the problem. A technician will apply a quick procedure to test and see if it solves the problem. If a quick procedure does not correct the problem, you might need to research the problem further to establish the exact cause. So for example, like somebody has set the static IP address and the user says, okay, well, I can't go to the internet. You go and check the IP address, do the IP config, find out wrong IP address. You think, okay, well, that is the cause, static IP address instead of dynamic. You change that and you fix the problem. So on 3 steps. But if you can't fix the problem, you have to research a bit more. If it's not as easy or you're not experienced on fixing the problem. Step number 4 is to establish a plan of action to resolve the problem and implement the solution. After you have determined the exact cause of the problem, establish a plan of action to resolve the problem and implement the solution. Step 5. Verify full system functionality and implement preventive measures. After you have corrected the problem, verify full functionality using ping, traceroute, if applicable, implement preventive measures. So making sure that users maybe they don't have access to change the IP address and so on. That was the problem that we were talking earlier. Step number 6. Document the finding, actions, and outcome. In the final step of the troubleshooting process, document your finding, actions, and outcome. This is very important for future reference. So let's go through the steps again. Step 1, identify the problem. Step 2, establish the theory of probable causes. Step 3, test theory to determine the causes. Step 4, establish a plan of action to resolve the problem and implement the solution. Step 5, verify full system functionality and implement preventive measures. Step 6 is to document what you did, outcome, and actions. If you're doing troubleshooting, troubleshooting comes with experience. The more you troubleshoot, more you will have experience to troubleshoot the problems. When you troubleshoot, like when you try to implement a corrective action, try to do it one at a time. So don't implement like 2 or 3 fixes at the same time, because then you don't know which one fixed what, and you could cause more problems than you're actually fixing. So test one, maybe change IP address or whatever you're thinking that's the problem. Try that. If it's not working, you have to go back. Make sure you revert to what it was if it didn't fix the problem. Resolve or escalate. In some situation, it might not be possible to resolve the problem immediately, and the problem should be escalated. This is usually done when the problem requires a manager's decision, some specific expertise, or network access level unavailable to the troubleshooting technicians. So maybe you don't have access to some, like you're not expert on maybe firewall and you don't have access to it. So you need to escalate the problem, because when you think, okay, well, it's the problem, it's in the firewall. So you need to escalate the problem. Maybe you do need to change the router. Maybe module on the router is not working. Then you need to escalate the problem so the manager can buy you the module. So for example, after troubleshooting, the technician concludes a router module should be replaced. This problem should be escalated for manager approval. The manager may have to escalate the problem again, as it may require the financial department's approval before a new module can be purchased. A company's policy should clearly state when and how a technician should escalate the problem. So verify and monitor solution. When a problem has been solved and a solution implemented, it is important to verify the system operation. So verification tools include ping, traceroute, and show commands. So for example, again, let me show you this network that we've been using. This is our network. Here we have everything is working correctly, 100%. I'll put the PC, if you're watching in the section 1.1, I didn't have this PC. Now I put it on there. And all devices, they were talking to each other. So if I say ping, for example, from router 3s to loopback, so from G00 on router 3 to loopback 10.1.1.1. So for example, ping 10.1.1.1, source 10.1.3.4.3, and I see it, no problem. I can ping. So that's the verification. Well, I can use traceroute. Traceroute, you learned early on. Traceroute, for example, 10.1.1.1. You can see that I can trace to the destination. So that is one way to do it. Then there are many show commands that can be used to narrow down and display information about particular and specific aspects of iOS. In the output interface, up and up can send and receive traffic while administrative down interface are shut down. So for example, if I go to my router and I say show IP interface brief, now all my interfaces, if it's layer 1, that's layer 1 status, is up, layer 2 protocol is up, then this interface is working, layer 1 and layer 2, and it's got an IP address. So up to layer 3, I see this fine. But if it's administratively down, then obviously it's not going to talk. So by default, interfaces on the router are administratively down. So they're shut down. So you as administrator, you have to go to that certain interface and do no shutdown. So for example, interface G00, no shutdown. And then show IP interface brief, show IP interface brief, show IP interface brief, then interface is up. Which one did I do? G00. It's already up. So let's do G01. Config T interface G01, no shut, and show IP interface brief. Now there's nothing, well, there's no any, I don't have any neighbors on it, but it's G01 is already connected. So you can see that layer 1 and layer 2 is up, but it doesn't have an IP address, so there's nothing going to be talking from there. The duplex in data communication, duplex refer to the direction of data transmission between two devices. Half duplex communication is restricted to the exchange of data in one direction at a time. Full duplex communication allows the simultaneous sending and receiving data. Interconnected devices must operate in the same duplex mode to avoid problem on the link. Ethernet auto negotiation facilitates this configuration and therefore minimizes the problem. So if I go to the say router 3, let me shut down that interface, G01 shut. If I say show interface G00, for example, then you can see that, okay, well, the duplex is full and it's 100 Mbps, but we can change that duplex. So if I go to that interface G00 duplex, I can put full auto, which is enable auto duplex configuration. This is what it should be anyway. Or put a half. The other side of the switch, because this is connected to the switch, if I say do show CDP neighbor, see G00 of my router is connected to the switch DLS1 FA03. That is full duplex. So if I change this to half duplex, there's going to be problems. So duplex half. So you see that some of the errors we'll see. So look, we already lost the neighbor, the OSPF neighbor that we had with the 0, 0 of router 4. So duplex has to match on both sides, yeah. So if I go to, for example, say to DLS1, show CDP neighbor, so it's connected to router 3, and if I say show interface FA03, you can see that this has been set to half duplex because this side is auto. So if I go to interface FA03 and this side I say duplex full, I was not receiving any messages. Now the duplex is not matching because I said duplex full in this side and half duplex on the other side. And you see right away some of the CDP messages that we're getting. Duplex mismatch discovered on fast Ethernet 03, not half duplex, we are full duplex. With router 3 gigabit 00, which is half duplex. So duplex has to match, yeah? So let me just go and configure that. Interface FA03, fix that problem. Duplex auto. And control shift 6X, and then I go to router 3. Config T, interface G00, and I say duplex full or auto. So always auto will be good. So if one side is full and the other side is auto, half duplex, it's not going to work. And there's a problem because things they kind of like work, but not 100%, yeah? So duplex mismatches might be difficult to troubleshoot. As the communication between the devices occurs, this may not become apparent even when using tools such as ping. Cisco Discovery Protocol, CDP, is a Cisco proprietary protocol that can detect a duplex mismatch between the two Cisco devices. So for example, I did set the switch, and you can see the messages that were appearing. Duplex mismatch, and you can see fast Ethernet and so on. Then IP addressing issues on the iOS devices. IP address related problems are often the reason why remote network devices cannot connect. IP address assigned to a host must conform to the network's ranges of the address. Wrongly assigned IP address creates a variety of issues. Two common causes of incorrect IPv4 address assignments are manual assignment mistakes. So if you just sign in manually and you make a mistake, or you created a DHCP related issue, so for leased IP addresses. Use iOS show IP interface or show IP interface brief commands to verify which IPv4 addresses are being assigned to the network interfaces. Now for the PCs, if the PC has been set, well, it should be set to get an IP address from the DHCP automatically, and if the PC cannot talk to the DHCP, it will assign itself a 169.254.004/16 range using the automatic private IP addressing PIPA features. So this feature is like, okay, well, if I can't connect to my DHCP, let me just assign myself an IP address. It's like a kind of like a rollback. If say DHCP fails for some reason, your DHCP server fails and it's not leasing any IP addresses, then at least your clients can assign themselves an IP address from this range, and they will be able to communicate with each other on local area network. That's why it's called link local. They can't go to another network. They have to talk to each other on the same network only. Use the Windows ipconfig command to verify the IP address configuration assigned to the Windows based host. In Linux it will be ifconfig, but in Windows we have ipconfig all. Then we have ipconfig release. So ipconfig all will display all the configuration. Then we can release our IP address to the DHCP, and we can try and renew our lease. So for example, I have here a PCA. Let me resume that. PCA was connected to, if I show you here, that's a PCA connected to. It's got a connection to these both routers, and it's got a static IP address. So for example, PCA, because it doesn't, let's have a look. Let's have a look at the PCA. So if I connect to PCA, and you see PCA doesn't have a default gateway. So as far as the PCA is concerned, it can't ping this loopback. Without default gateway, it won't go there, right? So if I go to PCA and try and ping that, so ping the loopback of router 1, it was a general failure. It's like nothing is connected. So let's just ping router 3, 10.1.34.3. That is router 3. 10.1.34.3. Okay, so we're pinging that address. Let's see. Yep, that address is fine. So as you can see, because we don't have a default gateway, there is no, it can't go to the other side of the network, right? If you check, do for example ipconfig/all, this will show you the interfaces. For example, here, that's our interface. Where is it? Here, this one here. It's a virtual machine, yeah. So that's a MAC address here, right? And you can see the DHCP enabled. No, so that tells me right away that this is a static IP address, and we don't have any default gateway, and the IP address is this. Okay, so if I want to configure the IP address, so go to Start, Control Panel, then View Network Status and Tasks, change that to Settings, right click this, go to Properties, and right, you can see this IPv4 static IP address. If I click Obtain IP address automatically and the DNS, you can see that this tab appears. If I put static, that tab disappears. So this tab is about APIPA, so automatic private IP address is going to get. Right, so the PC, if we set this, right, let's see, because this is a VMware, so hopefully it's not going to get an IP address. ipconfig. Now, let's try again. ipconfig. See, it asked for DHCP, and DHCP, it wasn't around, so that's what it did. It assigned itself an APIPA address, 169.254.87.174, just so it will be able to communicate if anybody else couldn't assign an IPv4 address, or you couldn't lease an IPv4 address from the DHCP. So if you come here and you do ipconfig and you see this address, you know that this PC cannot talk to the DHCP. It was set as a DHCP client, but it cannot find the DHCP. So you can do two things. You can troubleshoot the DHCP, or you can here come and set an IP address that it's going to be part of the network. Set it static IP address, just to confirm that it's talking. So address is 10.1.34, and that 34 network, .5 we picked, and it's subnet 255.255.255.0. Now, if I do that, ipconfig, right? Let's try it. Let's wait a few seconds. ipconfig. Here's my IP address. Now I set it statically. Now if I ping my one of the routers, 10.1.34.3, I'll go reply. But if I ping a remote network, 10.1.1.1, I don't, because I don't have a gateway. So here, properties, you put the gateway, 10.1.34.3, for example. So now my router 3 is the gateway. Multiple default gateway is because the other interface. Let's try this. Now we can ping the remote network. Again, another thing that you need to check is that the subnet mask has to be the same. So if I put 0 here, for example, right, that message is because I got two interface cards and this one has got different gateway, right? Now, even though the IPv4, if we put the subnet mask incorrectly, it seems that it might work, but it will cause you some problems. But anyway, make sure the subnet mask is correct, and it has to be on the same network. So if I put, for example, 33 here, that's a mistake, right? So here, another message that we get right away in the Windows, cancel this, try again, 33, for example, okay, yes. One message that I did click yes very quickly is it was giving you a warning. It was saying, okay, well, the warning is that your IP address is in different subnet to the IP address. Oh, let me change this because it's changed, yeah? Right, this is going to get a warning saying that your IP address client to the gateway is in different network. So the default gateway is not on the same network segment subnet that is defined by the IP address and the subnet mask. Do you want to save this configuration? Yes. It's not going to work now because we are in different subnets, right? So I can't ping anything. Let's try and ping the 34.3. I can't even ping that one because I'm in different subnet. So let's go and fix that. Let's put 34 here and click OK. Yeah, it's fine. Okay, let's go back to our slides. Default gateway we just talked about. All hosts wishing to communicate with outside hosts must have a default gateway configured. The default gateway address must belong to the same network as the end device. The default gateway address can be set manually or obtained from the DHCP server. Problems are related to misconfiguration of this DHCP problems. It is important to verify that a proper IPv4 address and subnet mask were configured on the router's interface and then the interface is active. To verify the default gateway on Windows-based computers, use the ipconfig command. To verify the default gateway, we said ipconfig. So if I go to that machine here, if say ipconfig, you can see that that's my default gateway. So it's correctly. So if I ping my gateway, ping 10.1.34.3, see, that's no problem. And I can ping the remote network. The remote network, if you look, it was that one there. So we'll try ping 10.1.1.1. Yep, that's no problem. On the router, use the show IP route command to list the routing table and verify the default route, aka default gateway, is set. So gateway of last resort should be right all zeros, somewhere to point to all zeros. So imagine, what I want you to imagine is that this loopback is representing the internet. Yeah, so if I put this is internet, right? So on router 1, I have to put like a static route that says any networks, any destination that we don't know about it, I'm gonna just send it that way. Yeah, so I say okay, config t IP route any network with any mask is gonna go towards loopback 1. Loop. Do we have loopback 1 or loopback 0? That's right. Do show IP interface brief. There's no loopback. Oh, this is router 3. Let's go back to router 1. Control Shift 6 1. Do show IP interface brief. Yeah, we have a loopback 1 here. So I'm going to configure a static default route. So exit IP route any network with any destination, any mask. It's going to go to loopback 1. Right? So if I say show IP route now, you can see that in there it says, okay, well, any network with any destination, any destination with any mask, we're going to go towards loopback 1. And this, we have to replicate this to other routers. So if I go to router 4 here, for example, show IP route doesn't have a default gateway set. So that's not like, it's not like default gateway. They don't have it here. So I have to go to router 1 and redistribute that default route. So that is done on the routing protocol. So router OSPF 1 and default information originate. Okay, let's spell it correctly. So default information originate. It's easy to tap. Don't worry about spelling. Use the tab key default and hit the tab. It will fill it for you. Yeah, originate O tab will fill it for you. Right. So if I go to router 3 back, router 4 back, show IP route now, and now I should see a default. So gateway of last resort is set to 10.1.34.3 because this is telling for any network, and this is external OSPF route. So now router 4 knows how to do it. So if I say trace route, so for example, say network, I don't know, let's say 123.123.123, it doesn't exist, yeah, right? So all the way it's going to router 1. It's getting to router 1, and then, well, it stops because that doesn't exist. Router 1 doesn't know what to do with it. He's trying to loop back, it's not working, and so on. To stop this, Control-Shift-6 twice. Okay, go back to our slides. So troubleshooting a DNS issue. Sometimes, you know, if you get a wrong DNS server from the DHCP, the wrong DNS IP address assigned to the client machines, they can't access any domain, because users will usually type the domain name, and the DNS is supposed to convert these names to an IP address, or resolve names to an IP address. So that's some of the problems we could have here. For example, if I go back to our client machine, if I do ipconfig, there's no DNS. ipconfig /all, there's no DNS because I haven't configured anyway. So if you look, it's not even showing here. It's nothing because I didn't configure. You can use an NS lookup to find out. The thing is with DNS, if, for example, for some reason you expect it to work and it's not working, you can do this command: ipconfig /flush DNS. That's gonna flush the cache because for some reason your cache could be corrupted or something, and this command will flush the cache, will start fresh. Or another thing I can show you is the DNS. The first thing the DNS is gonna do when you boot this machine will take the anything they stored on the host file, and it will add it to the cache, right? To get to that host file, what you need to do is you need to start a notepad, but in the administrative privileges. So notepad, right? And I have to right click here and say run as administrator. Then once this notepad starts, you can say file, open, and then go to the C drive. So C drive, Windows, System32, right? And then go to let's look here, drivers, etc, and then it doesn't display anything. But here you can say, okay, well, I don't want to see text document, I want to see all files. And then there's this file, host file. Here, whatever you have configured here, that's going to be first in your cache. So you can say, okay, well, don't put this, because that's just it's not going to read it. So for example, say IP address, say 123.123.123.123, and say here you can say www. I don't know who you want to say. For example, ABC company .local, and this is going to go automatically on your cache. Automatically, it's going to go to the cache, right? Okay, so what we have, anything else? Nope, that's it. Thank you very much for watching. Please have a look at other videos, and don't forget to subscribe. This has been Astrid Krasniqi. Bye bye.